So you are getting your screen.
I'm sorry. Can you see my screen? No?
Yes, yes,
Oh,
yes.
okay, good. Okay. Let's see. Okay, good morning. First, yesterday, some student asked questions through the chat. So let me, the first question is what is the mechanism of CO2 storage when in the EOR? So generally, we talk about CO2. We talk about inject CO2 to increase the oil recovery. Meanwhile, we could store CO2 and in the reservoir. Okay, so simple explanation is when you produce oil, some pore volume is evaporated, right? So therefore, you could use those evaporated pore volume to store CO2. So that is a simple way to understand it. From this point of view, so if you increase oil recovery, basically then you increase the volume which could be used for store CO2. So that's the mechanism. But of course, you have other mechanisms. I will not make more complex, just simply you could understand it this way. That is the first question. And another question is, what is the mechanism to lower capillary pressure? And so what is the low IFT? So low, actually I recorded here, I'm not sure what exactly, what is the exact question. Okay, I see it's a low PC due to a low IFT. So now I forget what kind of exact question. Some student, I mean, if the student ask this question is already here, and can you explain what is the question? I have a simple note here, but I forgot exactly what's the full question. Okay, simply is, now if you have low IFT, so then your PC is it's your capillary number is high. All right. If the capillary number is high, okay, that's good. Let me show you simply I have here. Now, when the low IFT is low, then capillary number will be high. Let's say when the capillary number is high, let's go this way. What do you say? SOR reduced. If the SOR or the remaining oil is reduced, and then more oil recovered. So that is the mechanism to use the low IFT to increase oil recovery. Okay, that's the two questions. I answered to these two questions. And next one, we're going to talk about today's class. We talk about the simulation. Okay. So first, for simulation based on the function, simulators or based on the function, we have black oil simulator. What is black oil simulator? So black oil simulator is water, oil, and gas. Basically, you have three component. Okay. And then this gas can be dissolved in oil, can also dissolve in water. So that is simple is, so this oil is simply the one oil component. So this oil is described by the viscosity, density, and some other parameters. Basically, one single component using the different parameters to represent so this total oil. But as you know, actual oil, you could have different component, right? You could have C1, C2, C3, and C30, whatever, even higher. Okay? So then actual oil has many components. So if you consider different component, then we're going to use this simulator is called compositional simulator. So in this case, you have a component instead of assigned parameters for oil only. No, is assigned parameters like density and viscosity, something like that. Is not for oil anymore. Is for each component. Okay. So that's compositional simulator. Now, so far, either black oil or composition simulator, so far we assume temperature T is constant, temperature is constant. In other words, we are not consider the heat loss, heat input. The temperature is maintained constant. All the parameters are independent of, or all the parameters or properties are at the same temperature. But if you consider some temperature changes, now in other words, you consider heat transfers, then this is go to thermal simulator. All right. So we have thermal simulator. All right. So far, mainly we talk about temperature changes and oil composition changes. And we have not talked about injection fluid, how injection fluid changes. Now, in surfactant flooding, for example, so in the previous several days, we mentioned surfactant, right? Especially yesterday, we talked about surfactant, and we inject surfactant, add a surfactant in the water, so then it's called a surfactant assisted oil recovery. So this surfactant is complex fluid, and this surfactant dissolved in water. So you have then add some oil, then it's going to form a, okay, let me release some space. You have surfactant and water, and this surfactant solution reacted with the oil, then you're going to generate some chemical solutions. In these chemical solutions, you kind of new fluids. Or new generated fluids. How these fluids change with pressure, time, especially salinity. Okay, how this new fluids is going to change with the time, pressure, and especially salinity. So this, if we consider these changes, we're going to use chemical simulator. Okay, so now you understand we have, based on the different functions, we could have 4 types of simulators. Now, let's use the example here. In this example, you saw this slide earlier. These slides explain what kind of model I use to simulate. What do I did? I use this model to simulate gas, half, and puff, and gas flooding. We also use water, half, and puff, and water flooding. Okay, so that's what we did. Now, during this process, during all this process, we assume T constant, temperature is constant. So therefore, we do not need to use thermal simulator. And do we need to consider the different components in the oil? You could have yes or no answer. If we consider oil component, then we're going to use compositional simulator, which I did. So in this case, I used the compositional simulator, and commercial simulator name is CMG's GEM. But I could also, without consider detailed oil components, then we can use black oil model. Actually, in the beginning, I used black oil model. I use CMG commercial black oil model's name is CMG's IMAX. All right, so that's the simulator I used. And so in this, I did not consider detailed chemical reaction. And because I really knew this model, I did not simulate chemical UR. I did not simulate the surfactant behavior, surfactant. Okay. But other data I used the chemical UR, but I'm not going to talk about it today. All right. So that is based on what simulator I used. Next thing I want to explain to you is, let's come back to this model here. I said in this model, I assume here is half well, actually half. Here is another half well. Here is half fracture. Here is half fracture. Okay, so now in this model, So two half fractures, you have one fracture. Two half wells, you have one well. So by doing so, basically, because I0